Okay, what is the square root of negative 16? It's not 4, because 4 times 4 is positive, and it's not negative 4, because negative 4 times negative 4 is also positive. We have to invent new numbers in order to make this work. Just like in 3rd grade, you start talking about what is 3 minus 5. In 1st grade, 3 minus 5, there isn't any such thing because you can't count that on your fingers. But once you get the concept of a number line and things like that, you can start talking about negative numbers and weird decimal numbers. And now we're going to just define okay, I squared is negative 1. We usually try and write it that way rather than writing square root of negative 1 because have to be a little bit careful with that. All right, so this is going to be for I. Popping out the biggest perfect square, let's see, 48, 4 times 12, we can pull another 4, it's 16 times 3. So we usually put it in the order 4i root 3. It doesn't really matter, but we don't like to put the I after the square root sign because if it gets sucked under the square root sign, it becomes a completely different number. I squared by definition is negative 1. So 3i times 2i is negative 6. This is 2i times 3i, so this is negative 6. So notice you can think of the negatives under the square root sign as sort of half a negative sign. You need 2 of them to make a real negative sign. That's the way I've sort of decided I like it. Notice that the 12 and the 24, I can sort of cheat a little bit and make them both multiples of 12. And then I can have root 12 times root 12 can combine together to just 12. And you have square root of 2 left over. I squared is negative 1. And 12 times 2 on the outside combines. The root 2 on the inside has to stay behind. I squared is defined as negative 1. I cubed is I squared times I, so it's negative 1 times I to the 4th is I squared times I squared, which is positive 1. So notice that if we note that I to the 4th is 1, I to the 8th will be 1. I to the n is 1 if n is a multiple of 4. So a cute trick, we just pull out I to the 4th, and then we only have to know the numbers, what is I to the 1, 2, and 3. So I to the 4th is 1, so this is the same as I to the 3rd, which is negative I. Nearest multiple of 4 for this is 16. So this will also be negative I. Don't forget, whenever you take a square root, it's plus or minus. So x is plus or minus 2i. Okay, in this one, we compare the real parts and we compare the imaginary parts separately.
Imaginary is the part stuck to I.
Okay, so 2a is 2, so a is 1, and 3b minus 4 is 7, so b is 11/3. Okay. Multiplication, foiling properly, just don't forget that I is I, but I squared turns into a real number. So we have 12 minus 4i plus 6i minus 2i squared. And the minus 2i squared is minus 2 times minus 1, so it's plus 2. Another way to say it is I squared switches the sign. Okay, so if you multiply two complex numbers, a plus bi is what we call a complex number, you get another complex number. Notice that this is 5 plus I times 5 plus I. Okay, I'm going to add another problem. You be careful, because I've noticed in the past that that people automatically see parentheses and they start foiling. Okay, this is adding and subtracting, completely different. Distribute the minus sign. Minus 2i is plus 2i. So combine like terms. So just be careful when you do that. Division is an interesting little problem. There's a trick. Right today. All right. So switch the sign on the imaginary bit. Okay, so let me just rewrite this. Conjugate of 3 plus I is 3 minus I. And you're not allowed to just multiply it on the bottom. I'm going to multiply it top and bottom. And then I do a whole lot of foiling.
Foily, 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 foily.
Notice the reason that I do this is because then I end up with just a purely real number on the bottom. Okay. Now, we're splitting it into real and imaginary parts because we'll need to be able to do that for graphing complex numbers, which is coming on the next problem set. Okay, so the important thing about this is that complex numbers, a plus bi numbers, if you multiply them, add them, subtract them, divide them, you still get another complex numbers. It takes a lot more doing, but you can also like square root them and still get a complex number. Interesting.